Let's take a walk through one of our zero-touch orchestration solutions which enables high-performance engineering powered by BrillioOne.ai. This demo is based on a three-tier application also known as a microservices-based application. This demo is based on a three-tier application built as a microservice. The goal of this simple use case is where a developer is trying to deploy a new feature to existing applications in production after running across multiple iterations of different environments. However, it takes only a few minutes to view those changes in actual production for the end user, which ensures faster time to market and high-end user experience. As you can see, this is possible through orchestration capabilities like infra as a code, continuous integration, continuous deployment, and continuous testing, resulting in seamless continuous delivery, and also rollback in a case of any failures of the application in production environment. For orchestration, we are using Jenkins, and for infra as a code, we are using Terraform. And also there are different tools for continuous integration and deployment. As a part of this use case, the developer checks out and commits the code into a source code management tool, where the pipeline is auto-triggered for different stages. So here, stage 1 is infra as a code. Stage 2 is continuous integration and deployment. Stage 3 is continuous testing, and stage 4 is for the rollback. All these stages are designed as a separate pipeline, and each pipeline has its own jobs to execute. At stage 1, as infra as a code deploys or creates or provisions any required resources on different cloud service providers and across multiple environments like dev, QA, and UAT, there is also a control gate available in our demo where the operations team can approve or abort the creation of a resource before it actually gets provisioned in an actual production environment, which I will show you in a moment when we go to the actual demo. Stage 2 and Stage 3 are executed with different actions like unit testing, code coverage, code analysis, and also pushing the images to Docker registry and deployment to Kubernetes cluster on any of these environments. Also performing functional testing, performance testing, security testing through our continuous testing stage. Right now for the demo, we are only using functional testing for the UI testing using Selenium. A rollback feature is available to go back to the previous working version of the build, where there might be any kind of failures for the current build in production environment or in any environment. So all of these are automated and optimized for overall end-to-end automation. Furthermore, as part of high-performance engineering, there is continuous monitoring, continuous assessment, and continuous collaboration features available when it comes to enterprise solutions. So now this will help us to have much more value addition and also to compete in today's IT industry. Now let's move on to the actual demo where you see a different pipeline for each stage that we just discussed in this slide. So we are going to do a walkthrough of the actual demo. Here is an orchestration tool. We are using Jenkins. I am in the Jenkins console. As per the slide, we do have 4 stages, stage 1, 2, 3, and 4. Stage 1 is infra as a code, and when developers commit to the source code management tool, a pipeline is triggered for this infra as a code. Before any application gets deployed, it ensures that the actual desired state of the infrastructure is up and available for the application to be deployed. Here for the demo purpose, I am running with the parameters where we have an option to either create or destroy the resource. So this create and destroy can be like a control gate for the operations team to make a decision based on the requirement and impact if there is any change in the configuration. Before we move to creating or building the resource, let us go and see what is currently available in Azure. Just for the demo and because of time constraints, here I am creating a new resource as part of infra as a code. Currently there is only one resource group and the new resource needs to be created, which can take a couple of minutes to get reflected in Azure. Let's go ahead and build it. As you can see, there are different jobs getting executed, so it actually goes and creates a plan to compare with the actual existing environment, and if everything is fine, then it goes and applies that. During deprovisioning or destroying a resource, we can go ahead and run this job, which you can see in the previous job where once I create, I have gone and destroyed it and created it again. Now this build is complete. Let's go and see. Before we go and view that resource group, let's go and run this continuous delivery. So here I have integrated CI, CD, and CT as part of the continuous delivery pipeline. Let's go and execute this pipeline. Meanwhile, we will view the resource group. As you can see, there are different jobs being executed. As you can see, Stage 2 and Stage 3 are getting executed one after another. This can be executed in parallel, but as per the requirement, this can be customized, but everything is fully automated. So let's go check the resource group so you can see that there is a new resource group created as part of the Infra as a Code pipeline. Let's go back to continuous delivery pipeline, which is still in progress as you can see it executing in this pipeline. And these are different jobs where it builds and then performs code analysis, pushes the image to the Docker, and then deploys those images to Kubernetes as microservices both for the web tier and database. So let us go and view these artifacts in Azure. Here you can see your database and web tier. The latest build executed is number 92, and you can see that the artifact is also tagged as number 92. This is applicable for both web as well as your database. As part of continuous testing, once the application is up and running, it will go and perform UI testing. Now when it comes to rollback, this is where it is parameterized, where we can go enter previous working build versions so that it rolls back to the previous working version. We can build a web tier and a DB, which is a kind of microservice. Now we will go and check the application. It may take some time. Now let's go and review the reports we had for tests. This is part of the code coverage where it gives you an option to review and take any actions for improvement. When it comes to functional testing, the UI part also gives the results done through Selenium. We have results to review, what has failed, passed, and what are the different actions that we need to take to make changes to the code. We have also used SonarQube for code analysis, and this is based on the quality gates configured where we have the bugs or the vulnerabilities where we can go and review and analyze it to then recommend further improvement for DevOps or for the overall engineering team. Let's go back to the application and log in. It may take some time. There you go. We are actually inside the application, and this is sample data where we have done functional UI testing and also unit testing for the code. With this, we have come to the end of this demo. Overall, there are many reliable solutions available as part of the high-performance engineering to ultimately achieve one-touch automation with high-end user experience with high quality.